All right. Let us now go over the chemistry, the chemistry of life. So we talked about how biochemistry is the study of the molecules. It is the study of the molecules that compose the living organisms, and we have four different types of macromolecules. Carbohydrates, we are familiar with what they look like, the fats, the proteins, and the nucleic acids. Okay, so we talked about the Niels Bohr model. We said that protons have to be positively charged, and the mass is one atomic mass unit, AMU, and that is the mass represents the proton plus the neutrons. That's very important. You need to know that. And the neutrons is no charge, zero. And the atomic mass is approximately equal to the total number of protons and the neutrons. Electrons are in clouds or shells, different energy levels around the nucleus. They have a single minus charge. They have a very low mass, and an atom is electrically neutral as the number of electrons equals the number of protons. Okay, valence electrons. Valence electrons are in the outermost shell and they determine the chemical bonding properties of the atom. So here, this is very important. You should be able to tell that 6p plus means that's the number of protons. And 6e minus, that's the number of electrons. And 6n0 is the number of neutrons. Okay, the sodium has 11 protons, 12 neutrons, 11 electrons. So that shows you that the atomic number on the periodic table is what, so the periodic table orders for us numbers based on their proton number. So the atomic number is the number of protons. The atomic mass is number of protons plus number of neutrons. Isotopes. Who can tell me what isotopes are? We talked about those. What are isotopes? Yes.
Different variations of the same atom.
Excellent. Very good. Good job. So they are different variations of the same atom. So they have one thing in common and they have one thing that's different. What is in common between all the isotopes? Proton number is the same. And what's different?
Different mass.
Different mass. Yeah, because they have a different mass because they have a different neutrons. Excellent, 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 excellent. So let's look at hydrogen, deuterium, tritium. They are the classic example of isotope. Excellent, isotopes of hydrogen. So hydrogen has one, so they all gotta have the same proton. If you change, let's look at the periodic table. Let us now look at the periodic table. It's very important for us to look at the periodic table. Periodic table. You see, look, I want to show you, this one is good. Okay, this one is really good. You see this number here, 17, that's the atomic number. So hydrogen has 1, helium is 2, lithium is 3, beryllium is 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. Okay, so now let's go back to our slide. Imagine you add 1 proton extra to the hydrogen. What's going to happen now? If you add 1 proton extra to the hydrogen, what's going to happen? It's going to turn into helium because it's going to go from 1 to 2. So isotopes are different variations of They are varieties of an element that differ only in the number of neutrons and the atomic mass. So the atomic mass and the atomic weight. So that's very different, okay? So they all have the same atomic number because they're all protons. They just have different atomic mass. Okay, let's now talk about radioisotopes. Radioisotopes are very useful for radiology, for diagnostics. And they use that like for contrast medium and to be able to detect like any changes in tissue or any changes in the histology. That's all. Okay, we talked about what an ion is. An ion is a particle that has unequal number of protons and neutrons. Either too many plus too many protons, you are a, if you have too many protons, you are a cation. If you have too many anions, if you have too many electrons, it's an anion. Okay. Let's look at what happened between sodium chloride. It had 11 protons, chloride 17 protons. 12 neutrons, 18 neutrons, 11 electrons, 11, 17. So you see the number of electrons and protons was equal, meaning that the chlorine atom was, if the protons and electrons are equal, that means they're neutral. And now they're all equal, they're neutral. But look at what happens. One pair of electrons leaves sodium and goes to chlorine. So now you see that the number of proton the number of protons, the number of electrons drop. Number of electrons drop, making sodium an anion, while chloride gained an extra electron, making it an anion. So now what kind of bond is this? What kind of bond between chloride and sodium? Ionic bond. Very good. Very good. Okay, so salts are electrically neutral compounds of cations and anions that dissociate in water into ions and act as electrolytes. You see? So that's like sodium chloride. When you put it in water, water is going to dissolve it. It's going to break it. So sodium is going to bind with which molecules of water? Na is going to bind who? Which molecule of water? Na is going to bind oxygen. Very good. And chloride is going to bind hydrogen. Hydrogen. Very good. And when they break apart from sodium chloride, NaCl, so Na is positive, Cl is negative. That's, yeah, free radicals. Free radicals are unstable, highly reactive oxidative species. So they are very dangerous, such as the superoxide ion. So the superoxide ion, that's an example of a stable oxygen that gained an extra electron. That is oxidative stress. So who repairs that? It's the SOD. You see SOD? So SOD is superoxide dismutase. Superoxide dismutase. What does superoxide dismutase do? Superoxide dismutase is an antioxidant that converts the dangerous minus O2 into superoxide ion. So the superoxide anion is going to be converted into oxygen and hydrogen peroxide, and both of them are not dangerous. Oxygen is okay, and hydrogen peroxide. So what happens? We have superoxide. O2 is oxygen. That's good. You have minus. That makes you superoxide. But no worries. We have a very good antioxidant enzyme known as SOD. SOD stands for superoxide dismutase. It converts superoxide, that's why they call it superoxide dismutase, because it's mute. It mutes superoxide into oxygen plus hydrogen peroxide, H2O2. Oxygen, oxygen, and hydrogen peroxide. How good. Excellent. Okay. The superoxide dismutase is an enzyme that's an antioxidant, but there are other antioxidants like vitamin E, vitamin C, and carotenoids. These are really helpful. These are really helpful for removing oxidants. So a molecule has many atoms. Okay, so now let's talk about this structure. So now let's look at ethanol and ethyl ether. How are they different? Remember in our lab, we were supposed to weigh the volume of water, 10 milliliters of water, and weigh that, and then divide the mass by volume to get the density. Then we were supposed to do ethanol, and put instead of water, put an ethanol, and then weigh that. See how much does it weigh, then calculate the density. Now let's look at the difference between ethanol and ethyl ether. What's the difference? Well, how many oxygen do they have? This one has one oxygen. This one has one oxygen. How many carbons do they have? Maybe they have more carbon. This one has two. This one has two also. How many hydrogen? This one has one, two, three, four, five, six. This one has one, two, three, four, five, six. Huh. They have the same number of oxygen, the same number of carbon, the same number of hydrogen, but they have two different names. Why is that? I'm sorry? R group. What is R group? No, you're talking about the amino acids. It's the way they are arranged. So you see OH here is to the far right, while the O is in the middle. You see? You have CH3, CH2, OH here, and CH3O, CH2. That's here. So you can have 1 pound of flour and half a pound of butter and 3 eggs, and you can make a cake. Your friend can make pancake, and your other friend can make. So it's just different structuring. So they have the same structural formula, but they have the same molecular formula, but their structural formula is different. So structurally, they are not structured the same way. Okay? Clear? Make sense? So if you want to get the molecular weight, we add up. So that's carbon, hydrogen, and oxygen. And then we multiply carbon by the weight of carbon. So now let's go back 66. That's a typo. That is a one typo. Yeah. Okay. Yeah, glucose wish it got 66 carbon. Okay, so carbon is 12. 12 what? 12 pounds?
No, the mass.
12 what? Yeah, atomic mass? AMU! Very good, very good. AMU. You see, in the past, we talked about it right here. AMUs. We said, right here, you see? One atomic mass, atomic mass unit, AMU. Very good. You said 2 out of 3. You were always almost there. He said atomic. I was like, yeah, mass. Yeah, blank. She was going very good. Excellent. Very good. Very good. You're paying attention. Okay, so now we add them all up. Carbon times its weight, hydrogen times its weight, oxygen times its weight, then add them all up together. So on the exam, if I bring you a periodic table and tell you figure out for me the weight of water, what are you going to do? Water has how many hydrogen? Two. Each one is worth how much? And has how many oxygen? And it weighs how much? 0.9. That's 16. So 16 plus 2 is? That's the molecular weight or molecular mass. Okay, ionic bonds, we talked about those. Covalent bond, they can be single, double, or triple. Why did they not put triple? Oh my God. Triple bonds, triple covalent bonds where the nuclei share 3 pairs of electrons.
I have a question.
Yes.
So you see how with the Copeland bond, you got the single, the double, the triple. Can it vary?
What do you mean?
Like, can it be more than that?
No, no. That's the max.
That's right.
That's the max, yeah. You cannot have more than you can share one, like here, that's known as a single bond, or you can share two pairs, one pair, two pair, or three pairs. But you can never have more because we have only four, remember four terminals. We have north, south, east, west. We have four valence shells that we use. So you can use the four, but like here, you see, it's using the carbon uses four. One, two, three, four. So these are single bonds. Or maybe it could have three bonds on one side, one bond on the other side. Okay? But not all the atoms can do that. But some of them can have like up to three bonds on one side, one on the other side. But you cannot have four on one side. You can have three on one side, one on the other, or two on both sides, or one on both sides, or two on one side and two on the other side. It works like that, but not four. Good question. You see, now that's an example of nonpolar covalent bond where it is the bubble is the same 50-50. They're sharing it equal. One pair, each one get an electron. But here, even though it's supposed to be 50-50, they are sharing. The electron are spending more time around the red electronegative oxygen than the hydrogen. And we said why this is so important. Why is hydrogen bonding important? It's important for DNA and proteins. So proteins fold up on each other based on hydrogen bonding, while while the DNA is folded on itself based on hydrogen bonding as well. Okay, so we use it for conformational change. Now let's look at here. What's happening here? So the hydrogen bonding of water. Hydrogen bonding of water. So in hydrogen bonding of water, we see that the water is red O with two H's. Red O with two H's. Red O with two H's. So oxygen and hydrogen, oxygen and hydrogen, oxygen and hydrogen. So oxygen and hydrogen, both of them are connected. Both of them are connected like this. You see O minus and H plus, and both of them are you see how this connection is, and you need to figure out these dotted dashes so you can draw on the exam for me how the water molecules are in cohesion they are in cohesion, right? They are connected to each other. You know how some people they stick together with their arms like that? They are not with their arms. They are sticking together with hydrogen bonding. So you need to know the inter and the intra. So which bond is the hydrogen bond? Is it the intermolecular or the intramolecular?
And
Raise your hand if you think it's intermolecular. Raise your hand if you think it's intramolecular. It's inter. Very good. The covalent bond, is it inter or intra? Intra. Excellent. Excellent, excellent, excellent. Van der Waals are a third type of bonding, weak, just like the hydrogen bonding, but it is not as obviously it is not as strong as the hydrogen bonding. It's not as strong as covalent bonding, but they are important too. Okay, mixtures. Mixtures are so mixtures are important because they are physically blended substances, but they're not chemically combined. So each retains its own chemical properties. So what are the properties of water? The solvency, you see how it can dissolve with its hydrogen bonding, other electrolytes. Cohesion, they stick together to one another, water molecules. They stick together to one another through hydrogen bonding. And then there's adhesion, and that is when water adheres to organs. Like, for example, we got to learn in anatomy and physiology too. If you're going to be with me next semester, you're going to see that the water is encapsulating the heart. So around the heart, there is a sac called the pericardial sac. And this pericardial sac is like a bag right around the heart. And between the heart and the bag is a serous liquid fluid. So why is that important? So that when there's trauma or when you hit the rib cage, it doesn't hurt or injure the heart. It's like a capsule, a protective capsule. So that's an example of adhesion or cohesion. Adhesion, because it's adhesing to the heart. Also around the lung. The lung also has a protective capsule of water that is performing the cohesion, the adhesion. Chemical reactivity. Oh, we talked about that. Hydrolysis, dehydration. You see how the water react to split the bond and to join the bonds. And water is also for thermal reactivity. We talked about that the first day of class when we said that water is important for sweating. Water is important for sweating because it has a very high heat capacity and it takes a lot of sun heat in order to make the water evaporate. Okay? We talked about how this hydration sphere happened. So the red oxygen is facing the sodium. Red oxygen is facing the sodium while the blue is facing the chloride. Okay? Any questions so far? Anybody has any question? Okay, you said that the amount of heat needed to raise the temperature of 1 gram of substance by, so that just shows you the heat definition of heat capacity. Oh, now we didn't talk about this one. We got to talk about that one. Okay, so a solution consists of particles called solutes. They are mixed with a more abundant substance, so usually water, and they are called a solvent. So the solvent is the one who is dissolving the solute. So if you put salt in water, that makes water the solvent and salt the solute. So the solute is the one who's dissolving. So what's the difference between a solution, a suspension, and a colloid, and an emulsion? An emulsion. I didn't explain that part. That means I gotta get up. Okay. What's the difference between a solute, a colloid, a suspension, and what's the difference between a solute, a colloid? Oh wow. Anybody know how to make this bigger? Okay. Okay. What's the difference between a solute, colloid, suspension, and emulsion?
Lift the computer up a little bit.
Okay?
Lift the computer. Can you click the little square next to it? No, no, it's lift. It's awesome.
It's blurry?
Or it's a.
No, it looks reverse here, but when you open the thing, it's gonna change. But I have to look into how to. Hmm?
Now he said it's gonna show you the correct side.
Okay. Okay, so a solution colloid, and suspension all have a liquid, 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 in which you're dissolving a solid, in which you're dissolving a solid, in which you're dissolving a solid. Well, if then that makes it the same, right? Because if they all have a liquid in which a solid is dissolved. So why they have different names then?
They do different things.
They do different things. So what do you think is different now? The size. So in a solution, solution, in a solution, you have really tiny, small solids in a liquid. In a colloid, you only have proteins. Proteins in the liquid and looks like gel. Gel. Looks like white gel. Thick white, gooey gel. That's a colloid. So in the thyroid gland, there's a lot of colloidal tissue. And then in suspension, you have liquid solid. Liquid solid, you will have really big particles, really big particles. Like for example, sodium chloride. What is that? Is that a solution or a colloid or a suspension? I mean, sodium chloride, the one that escaped in a dialysis bag. Remember the dialysis?
Yeah.
So that cannot. Okay, first one is all of them liquid and solid, liquid and solid. For solution is really tiny,
Okay.
really small solids. Colloids are proteins, and suspension is really big particles. So, for example, sodium chloride, is that a solution in water or a colloid in water or a suspension? I'm sorry? Solution, because sodium is really tiny. It can escape through the dialysis bag. But now let's look at protein in a liquid. That one is obvious. That one is a colloid. That's a colloid. Now, what about red blood cells? Red blood cells in plasma. We said plasma is water with electrolytes and salt. So now you have salt solution. You put in it really big old red blood cells, huge blood cells. Is that a solution now? What is that? Suspension. So our blood is a suspension. So now what's the emulsion then? Emulsion, you don't have solid. It's a liquid in a liquid. Like the oil vinegar, you know the dressing for the salad?
Yeah.
Oil vinegar, that's the emulsion. When you have a liquid dissolving in a liquid. Oil vinegar, like breast milk, it has milk and fat. So now that's an example of an emulsion because it's a liquid in a liquid. So you should be able to tell me on the exam, what's a colloid protein in a liquid? What's a solution? Really tiny solid in a liquid like sodium chloride. What's the suspension? Is huge solid in a liquid like red blood cell in plasma. And what's the emulsion? Now that's like a liquid in a liquid, like the dressing for salad, oil, vinegar, or breast milk, fats.
You said our red blood plasma is an emulsion.
No, suspension. Remember, the suspension is liquid solid in big particles. So you have red blood cells in a plasma solution, or red blood cells in water.
And what was the example of emulsion?
Emulsion is like oil vinegar, the salad dressing, or breast milk with milk and fat. Breast milk. Why is breast milk suspension? Because it has what dissolved in what? Yeah, breast milk and fat. So the baby has a lot of colostrum, like breast milk and fat, and so the baby is getting a really nutritious meal. Yeah, good old days. All you needed was breast milk, fat, and milk. Now you gotta go look for more stuff. Okay, colloids. You see, protein and water. You see, that's the solution. That is oh my, is my face still there? Okay. Okay, why is this happening? Okay, that's full screen. No, I don't want full screen. I want
Oh, the one on the up there. Is it the layout?
this one.
Layout. Yeah, no.
Oh God. What is that?
YouTuber.
Wow. What is this? This is very strange.
Oh, because you're sharing your, you have to go down to the application windows onto the left. And you have to share
Oh boy.
on the, that bottom left.
Bottom left.
Left, up there, okay, there, down, under your screen, there. Now you share that.
Thank you. Now, is this recording though?
Yeah. Yeah.
Oh my God. So what do I do now?
Yeah, that again, share. The headspace is there.
Maybe it's this?
I think you gotta, just minimize Zoom.
How do you minimize Zoom?
As,
Escape.
yes.
So we can do this then? That's a little better?
Yeah, just say it like that.
No, I cannot shift that.
Right.
Okay, then let's do this. It's not allowing me.
You fix it, you save it, you save it.
No, I cannot move the thing. You see, I cannot move the mouse.
You are moving the mouse. You mean you can't move the PowerPoint? Yeah.
No, I cannot move the PowerPoint,
Get out of there. You're sharing your screen, so just go back. Oh, wait, what if you just
yeah. Okay, let's just do that. Okay, so that's a solution, a colloid, and a suspension. Okay, no more camera ever. Okay, so acids and bases. That's another issue. That's another very important issue. Acids and bases. So we said our normal range for acids is actually this one. I really need the camera.
I think you can do it. Well, you'll stop recording. On the right side.
Okay, whatever. Let's do this. Okay, I have 7.45. That's the maximum. And 7.35, that's the minimum. That's my physiological homeostatic pH. If I go, if I go below, if I go below 7.35, that means I am more acidic. If I go more than 7.45, that makes me more basic. So I don't need acidic, I don't need basic. So what does acidic means? Acidic, acidic means acidic means high hydrogen proton concentration. It means low basicity, is low basic. It means high pH, and it means low hydrogen hydroxyl. That's very important. Then for basic, for basic, for basic, you have low hydrogen proton concentration, you have high hydroxyl concentration, you have, no, for acidic, you have low pH, that's a mistake. and you have high pH, and you have high, and you have low acidity. You have low acidity. That's important. Me being acidic, it means you have high hydrogen proton concentration. It means that you are not basic. It means that you have low pH, and it means that you have low hydrogen hydroxyl concentration. This is very important. Then for basic, you have low hydrogen proton concentration, which means you have high hydroxyl concentration, which means you have high pH, which means you have low acidity. So on the pH scale, if you go, 1 is the most acidic. That's hydrochloric acid. That's the most acidic. That's in your stomach. 15 is the most basic. That's NaOH. That's hydroxyl. That's sodium hydroxide. 7 is neutral. Okay? 7 is neutral. So 7 is neutral. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so what does that mean? That means if you drop in pH, so the formula says what? It says that pH equals negative log of the hydrogen proton concentration. It means negative log of the hydrogen proton concentration. So what does that mean? That means if you drop from pH 11 to pH 10, you have increased hydrogen proton concentration by 10 times. If you drop from 10 to 9 by 1 unit, it means you have multiplied hydrogen proton concentration by 10 times. If you drop from 8 to 7, you have multiplied hydrogen proton concentration by 10 times. If you drop from 7 to 6, it means you multiply hydrogen proton concentration by 10 times, and vice versa. If you go up from 2 to 3, it means you subtracted, you drop hydrogen proton concentration by 10 times. If you go up from 3 to 4, it means you drop hydrogen proton concentration by 10 times. So that's what logarithmic means. It means 1 unit equals 10 times. So if you go up 1 unit, you increase hydroxyl concentration by 10 times, and you drop hydrogen concentration by 10 times. And if you drop the pH by 1 unit, you increase hydrogen proton concentration by 10 times, and you drop hydroxyl concentration by 10 times. That's what the logarithmic means. Oh wow, time to go home. Okay, please go home. We'll go over the acids and bases again before we start next lecture. I'll post for you all the